Aibowan. Welcome to the webinar on resource circulation and industrial ecology, organized by the Lanka Responsible Care Council together with Deakin University, Australia, and INSEE EcoCycle Lanka Private Limited, providing the technical support. Let me first welcome our resource persons. Professor Ajit Dialvis, Professor in Chemical and Process Engineering, Department of Chemical and Process Engineering, University of Moratuwa. Dr. Mayuri Vijayasundara, lecturer from Deakin University of Australia. And Mr. Sanjeeva Chulakumara, Director, INSEE EcoCycle Lanka Private Limited. I welcome all three of you to this webinar. I cordially welcome all the participants joining the webinar virtually. As you already heard, the title of the webinar today is Resource Circulation and Industrial Ecology. Post-COVID-19 economic development needs to divert from conventional economic development world had prior to the pandemic, which was conventional linear economic model where we extract resources, causing huge damage to the environment, ecological systems, produce and use products and services, and then dispose the remnants to the environment, again causing damage. This needs a paradigm shift to meet the new challenges emerging with the changing global scenario. Today's webinar will try to address this issue and try to show some directions and especially learning from the world what Sri Lanka can do. Without taking any more time, let me introduce our first speaker. Dr. Mayuri Vijayasundara graduated from University of Moratuwa and then received a PhD from University of Melbourne, Australia. She is a chartered management accountant as well and currently serves as a lecturer at Deakin University, Australia. Dr. Mayuri will provide a short introduction to the theoretical concepts behind the topic and then later come back to discuss the global scenario and experiences in resource circulation and industrial ecology. Over to you, Dr. Mayuri.
Thank you, Mr. Perez. So I will share my screen. So it's great to be back to speaking an audience in Sri Lanka, an industrial audience. I think I'm doing that after about 10 to 12 years. It's great to be sort of sharing what I know and I mean what I can contribute to, like go to introduce the concepts to you. So I mean, how we go forward with the structure of the webinar is that I would be introducing the concepts of industrial ecology and a circular economy. And so Sanjeeva would speak about the best practice case studies on resource circulation in Sri Lanka. I would come back and elaborate a bit more on the global best practice case studies, and Professor Alvis would then take forward by highlighting how it can be applied to Sri Lanka. So let me directly go to the concepts to describe them. The principle of industrial ecology is actually nothing more than how to manage the industrial ecosystems to create harmony with the biological ecosystems. So if you think of the industrial processes, industrial material flows, and everything that is integrated to an industrial system, if we can manage them in a manner that we reduce the environmental impact and basically reduce the harm to the environment, that is the principle of industrial ecology. So in doing that, industries who basically provide the materials. So if we think of the scenario where waste of one product of one industrial process becomes a raw material or an energy source to another industry, the one who's giving the industrial resource will become a resource donor, and the one who accepts has become a recipient. So it could be the case that it's a direct material transfer, or it could be the case that there's a need for an intermediary who would convert the waste from that industry, recipient industry, and converts it to a raw material or an energy source to be readily used by the recipient of the respective recipient. So the key characteristics of the principle is that the systems thinking, we think of it as a system where a man-made ecosystem operates in a similar way to a natural ecosystem, and there's multi-directional nutrient flows, and the system objective of the system as a whole is to reduce the dependency on the environment. So the example I've taken here is a tree. A tree basically having interactions with the atmosphere, absorbing carbon dioxide, having the operation called photosynthesis. There's carbon sequestration happening. It interacts with the microorganisms in the soil, and has basically exchanges with the soil as well as the atmosphere. And whatever basically comes from the tree, fruits or leaves or whatever, gets absorbed to provide nutrients to the earth. So the principle here is that we don't take too much and we don't emit too much. So there's, so the entire system, basically, the tree operates in a manner that it has a natural balance with the external environment. So that's what we want the industrial systems to be ideally. Let's talk about the concept of a circular economy. And I think the best way to start describing is by going to the fundamentals of what the key economic activities are. So economies are centered around producing, distributing, and resources, or goods and services for consumption. So those three we call as the key economic activities. And in a linear economy, basically, we to produce, we extract resources, and we produce them, distribute them, and after consumption, we have another aspect to deal with, which is waste treatment. So basically, in a linear economy, at the beginning and at the end, we have detrimental activities happening to the environment. And the alternative models to this could be, I mean, there are different types of concepts you can talk about when you talk about alternative economic models. Something that we are quite familiar with is a low carbon economy. So basically, if you have the economy operating in a manner to give the same economic output but have less greenhouse gas emissions, that's one way to think about it. A dematerialized economy is where we have the same economic output created, but then we try to do it with less resources. The primary principle of a circular economy is that we attempt regeneration. So we try to regenerate resources within the economic system, and we try to do it not only not only after consumption, not only considering post-consumption waste, but the system as a whole. So if you think of the economic activities after consumption as downstream activities, and the ones before that, basically production and distribution, and anything that contributes to produce things to consume as upstream activities, circular economy is about designing the system as a whole, designing production, designing distribution, and also designing consumption and markets, so that there's a possibility to circulate nutrients within the system. So the concept, like the initial, if you think of the fundamentals of the concept, come from two main thought leaders. So one is Michael Braungart, and the other one is William McDonough, who talked about this concept probably 20 years ago, and they came up with this idea that less bad is no good. So when you talk about sustainability in general, we usually talk about the aspect that we like to reduce environmental harm or minimize environmental damage. But they said, no, it's doing less harm is still not good enough. So the idea to design things differently so that the regeneration is possible is the next step that they suggested, and they also suggested mechanisms how to do it. And the idea basically has we kind of think about two types of nutrient cycles within an economic system: biological nutrients and industrial nutrients. So biological nutrients are anything that interacts with nature. For example, if you have biodegradable waste degrade into compost, then we are adding an addition to the as a biological nutrient. An industrial nutrient is anything that goes around, like anything that gets converted to different forms as industrial material flows within an industrial system. So if you think of goods supplied, if you think of goods, if you think of them as products, they are made of components and they are made of materials. Components are made of materials. So if you basically design the economic system in a manner that everything after consumption either become a biological nutrient or an industrial nutrient, that is the objective that they talk about as the ultimate of a circular economy. So to do that, the design of the system, upstream and downstream, needs to change as a whole. So that is like a brief introduction. And this is the book that they wrote, Cradle to Cradle, remaking the way we make things. And if you're a person interested about sustainability, I strongly recommend reading this. And to summarize, the two economic systems. A linear economic system is an extractive economic model which generates waste. We have extraction happening. While producing, we generate emissions. We have waste disposal happening, again, which is not good for the environment. The philosophy, the products, how we basically produce things in a linear economy is we optimize on a few aspects. We optimize product performance, we optimize cost, and aesthetics, or the other functional elements of a product. Whereas in a circular economy, it's a regenerative industrial model which has an objective to regenerate resources within the system. And the philosophy is that the criteria for designing things also takes into consideration regeneration as an essential aspect. So with that, I would hand back to Mr. Pires, and I would talk to you again about when I share the global best practice case studies. Over to you, Mr. Pires.
Thank you, Maureen. I think before introducing the next speaker, I would like to invite all the participants. If you have any questions, kindly send it through the question and answer the box you can see in the screen. So we'll be able to answer these questions at the end of the presentations. Our next presenter is Mr. Sanjeeva Cholukumara. He is the director of INSEE EcoCycle Lanka Private Limited, and also he is a council member of Sri Lanka Institute of Environment Professionals of Sri Lanka. And he is actively involved in finding solutions for the big problem we have in solid waste management. So Sanjeeva, it's over to you.
Hi, Boan. Good morning to everyone. It's a pleasure for me to talk about on this very interesting subject with very interesting doctor and professor. And I'll be talking on local cases, especially on these two subjects, industrial symbiosis and circular economy. And before move on to the presentation, Dr. Mayuri very well explained this area. We are in a linear economic model. We have many economic activities, and we are using raw materials and energy, and we produce what we want, the services and product. Ultimately, the waste is being generated. 3.8 billion waste approximated generation is in 2020 in the world. When it comes to Sri Lanka, it could be around 2.4 million tons of waste here. So we have two ways of doing business or living in this society, linear or circular economy. So I will not go into details, but very briefly, we have to go away from linear economic activities like take, make, and dispose. You get waste and waste and waste, and your entire technical and biological material is really messed up, and you use finite energy sources. Whereas circular economy model, you have your biological and technical material very separate, and you enrich your biological materials and your all technical materials, you are returning back by closing loop. This is very simple concept, but it's very difficult to practice. Right. What I'm trying to give you is that getting INSEE as an example to give you industrial symbiosis and circular economic practices that we have done with our partners to get an understanding on these two subjects. And very briefly, INSEE is a cement manufacturing company. We have concrete and light building materials, aggregate, and also waste management business. And please try to understand, because I'm going to talk about the industrial symbiosis and circular economy options in cement business. So I want you to have a good understanding about the cement manufacturing process. It's a complex process, but we have main components like we need to have an quarry, and the main raw material is limestone, and we extract limestone and we heat it up and we get clinker. And to heat it up, we need both electrical and thermal energy, and then we have product and the distribution. This is simple cement business. However, in terms of sustainability, cement business being a thermal and material intensive process, so key driver is the sustainability for any cement industries. And we have taken this up in Sri Lanka. We have actually celebrated 50 year of cement manufacturing in here. So basically I have 3 areas in my presentations to showcase this 2 subjects. One is the waste management sector. Other one is cement production. And the last one is innovation to industries to futuristic thinking on these 2 subjects. Let me take the first subject, the waste management is a national issue. And the technology that we are using is cement kiln co-processing. I'll come into more details, but before that, let me explain the ecological misbehavior in Sri Lankan context, right? And ministry had identified many challenges. One of that is the waste and the product of the result of linear economy. And we have contribution cooperation for this resource extraction, disposal of waste, discharge to environment, and emissions. These are the component actually in linear economic model. And also you can see many related news on this subject. I don't want to go into details, but it's still a national issue. We need a sustainable solution for this. And also, unfortunately, we had in 2017 the unmanaged dump yard collapse causing 30 dead. This is the significance of this problem. For me, this is an real example of the result of linear economy without thinking on circular economy practices. Very briefly, the waste management option that we have, the main common practice still in Sri Lanka is the open dumping and burning. And INSEE EcoCycle is doing industrial waste management and also some non-hazardous waste. And also we are talking about few waste to energy plant and some few landfilling. So with this understanding, let me coming back again to a cement co-processing. The co-processing is quite famous in other parts of the world, but when it comes to Sri Lanka, only INSEE has its integrated plant in Putlam, so we only can do this in Sri Lanka. This is an very good technology to dispose waste. Basically, we get very good temperature, 2000 centigrade temperature. You have resident time about 4 to 6 seconds, and you can ensure the total destruction of material, and there is no organic residues from the process, and also we control emissions in continuous manner. So this is the technology that we use, and coming back to the topic, I want to explain you very briefly the waste management hierarchy. And the co-processing is considered as an recovery method. And what we recover is mainly 2 things, energy and mineral. So we are getting these 2 recoveries from waste. And also the co-processing is considered as a sustainable development concept. and also is a forward thinking, and we can use someone else waste or byproduct into this system. And this is very interesting slide, and I explain you the cement manufacturing or clinker manufacturing processes and thermal intensive process, and you need to have thermal energy. The source for thermal energy in Sri Lanka is coal, and you can see, and we are supplying this energy from waste, right? And you can see 34% of last 2 years total thermal energy supplied from waste, while also we are adding some minerals to the system. But this is a cumbersome process, like we need to have a lot of quality control, we need to have an pre-processing technologies. But what I am trying to tell you is that by doing this waste management at cement plant, we can save coal, we can solve national issue, and we can support industries. Ultimately, we can save the foreign cash. And also, I want to really stress the next slide, the co-processing and the incineration are two different techniques, two different method of treating waste. And you can see the first graph, the red one is the waste incineration. And if cement manufacturing is without and waste co-processing, you can see the amount of SOx, NOx, and CO2 emission. But if you can combine these two processes, you can see the significant reduction of emission that we can achieve. That is why the co-processing is a circular economy based industrial symbiosis technique, right? And I will not go into details, but for last 17 years, we have served these industries: agriculture, automobile, ceramic industries, metal, so and so, FMCG, etc. But what I'm trying to tell you is, so through this technology, so we have been given our service to these industries to run. They are businesses with an least ecological footprint. And also, just for information, some of the waste which cannot be co-processed, like radioactive waste, asbestos, explosive, and anatomical hospital waste. So that is about industrial waste. Another example that I want to bring you is on this subject is we have developed solutions for industrial biomass. And this has a long history. In those days, 15 years back, Putlam area, you have many rice mills. In those days, these rice husks were dumped, burned, and unattended. But we came into picture and we developed a sort of a CSR aspect project. Finally, we made this as a commodity. Now there are very good sustainable practices. The trucks, they are coming to bring cement. They are coming with the rice husk, and they unload the rice husk and they are going back with cement. So we have embedded all supply chain. Ultimate, we have net CO2 benefit as well. And also another area that I want to really touch is e-waste misbehavior. And the right corner picture, if you can really see, we took this picture at Kurunagala, Mawatagam area. And people has not really understood the consequences of burning. And this guy is just, he has a chamber and he just burn electronic. We have now established at our facilities is to take entire waste from electrical and electronic equipments, and after getting this, we disassemble these materials to send recycling or upcycling, and PCB we can export it to get an precious metal extraction. But a point to highlight here is, yes, we want to practice a circular economy, resource symbiosis, industrial symbiosis. But unfortunately in Sri Lanka waste, especially in electronic waste, it has a market. How they market is that only the PCB value. They go and pay, but PCB is only 5%, maximum 10%. But other part, again, they just dumped after getting PCB. But whereas we are giving an 100% solutions. Next slide is another, I would say, the national crisis. And this is exactly the example of linear economy model. You can see how biodiversity is contacting the result of linear economy. And also I explain about this waste mountain. And also you can see in Sri Lanka, waste dumping, it's happening to a great extent. And people are burning, polythene and other, combustible material without any control. And they don't really understand the impact of emissions that you have. I will not go into details, but if you really can see the dioxin health impact, you can get cancer, lot hormone system issues, and very many health impact. So knowing these cases, INSI came in and we have developed today a national level of solutions for municipal solid waste. Actually, this is another very good example to showcase in Sri Lanka this industrial symbiosis and circular economy. What we are covering entire BOI zones, because we have textile industry-based BOI zones, and we are taking all the textile offcuts which cannot be recycled to dispose via cement kiln. And also we are working with currently 90 local councils to get sorted municipal solid waste. This cannot be recycled. So this is another good example that we have adopted in Sri Lanka to practice or showcase this concept. And also I will quickly go into details. We have like advanced waste management services. When you really go into details, we have identified 2 types of waste generators, especially in industrial sector. We have a sector who need integrated waste management. These companies have their own waste generation in-house, like big companies. We are working with these companies, Lodestar, Colombo Dockyard, and Sales. So what we are trying to give them is, we will go into on-site and we will study entire value chain, and we will repurpose this waste to resource, repurposing these resources to resource recoveries or co-processing, or unfortunately we don't have scientific landfilling here, but engineering landfilling here, but we are trying to manage as much as possible waste dumping to a open dumping. And also another sector, this is advanced waste management product that we have adopted with companies whose waste is generated mainly outside. Of course, they have in-house waste, but there are majority of waste being generated outside. Example, the FMCG companies. It's scattered around the island. So what we are trying to help in this industry is to optimize our whole logistics to bring this material into one place. I will explain later, and then to promote recycling and recoveries as much as possible, while they need then brand security, because if discarded product goes to market, they will have an impact on their brand image. And recently we have, this is our newest facility. Yes, cement kiln has limitations. We have reached actually maximum level of waste acceptance. So we want to go beyond cement kiln waste management. That is why we have started resource recovery center, and we are hoping to handle actually 10,000 metric tons per year. And at the moment we started with Unilever. Now we are working with other FMCG companies to bring their waste. What we are trying to do is we will go island wide. We will merge our logistics. We will bring their waste, sachet, the containers, and also their expired product. We will bring it to one place, and we will, process it, and then we will we can recycle and upcycle this material. And one other area is what we consider as an industry on this subject is that the capacity development of partners in this area, because we have to work with partners like metal, e-waste, PCB, yogurt cups, soap, anything. So INSEE as a company, we are trying to develop these partners. We are trying to help them to improve their health and safety concern. We are trying to help them to compliance, to improve their compliance. And also we are looking actually, other countries, you can see the waste management associations, actually, they can collectively bargain to government. They can collectively have their concern. I'm sure if we really want to practice circular economy, end of the day, for us, like as a private company, we need to have a business case. So there could be an, the tax concession, some, some benefit for these companies to have an investment on this sector. And these are our customers. We have disposed as of today, as of last year, 7,000 metric tons of industrial waste, right? So that's about waste management in INSEE. And let me again, another second point is prioritizing business by fostering industrial symbiosis in new product development, right? I will go into details. Basically, we are moving from ordinary Portland cement to blended cement. In blended cement, you get other industries byproduct into our product portfolio. Before going into details, let me give you some idea about buildings or constructions. We have a very important ecological footprint. Freshwater footprint is high, wood harvest, CO2 emissions, energy, and raw material use is really high. So this industry has to think about the sustainability. And also, the next slide, you can see, irrespective of all crises throughout the history, and also this recent pandemic, and we have observed, or it's evident that cement demand is going up. And the current demand is 3,000 million metric tons. So therefore, even without anything, pandemic or crisis, the cement demand goes well. And also, world population is growing and urbanization is increasing. So these both trends will significantly increase society need for construction material. Therefore, and we need a cement industry need to think, and they need to have a research and development to develop cement with less CO2 or green, less CO2, consume less thermal energy, perform equally or better than common cement, support the overall commitment to a sustainable development, because cement business is really, really big. So with that, we have very good case in Puttlam. And in Puttlam, we have our fully integrated cement plant. Next to us is the Norochole power plant. They burn coal to get energy. And by burning coal, you get fly ash, right? Fly ash has lot many, environmental and health related impact. So what we have done is we went into details. We went to research and development to produce a product by using this fly ash. So we want to move from OPC cement to the blended cement. And this has more environmental benefit. This has more sustainable benefit. Industrial symbiosis can reduce the need of virgin materials also. And it's a fundamental feature of the circular economy as well. So, and this is very good case. And also other cement players are following us. That's really benefit, and our ultimate goal should be, because we need Norochole, so we need to have a solutions for fly ash as well. And also, the last part that I want to touch is the innovations to industries. This is our futuristic thinking on industrial symbiosis and circular economy based business. And we have our own innovation to industry center, I2I center. It's a, we would say, collaboration platform. Anyone, our stakeholders, universities, our customers, even our competitors can come and see and get our support to develop as an industry. So in this case, through our innovations, we have found a good innovative product from this sustainable innovation product, fiber cement. These fibers are from recyclable cellulose. This production is not available here because we don't have enough material, but we have this product. If there is a good, volumes, we should be able to bring this business to here. Another area that we are thinking in future on circular economy base, the end of life vehicles. you can see, actually, we went into details, find out how many vehicles have been registered for the last 10 years. We couldn't find data. But we found 600 plus vehicles registered in Sri Lanka. And also there are many accidents, and you can insurance claim, it goes to insurance yard. Of course, there are some, they can reuse this material. But we went into all scrapyard of insurance industries. You'll be wonder that there are many material which is lying and causing dengue and so many problems. So we are trying to develop solutions for them to have and sustainable solutions. Quickly, I want to touch we as a leader on this business. So we are working with universities, and we really want to establish this circular economy concept. We want to support as much as possible to industrial symbiosis. So we have, just for information, so we are working with universities. One example is corridors replacement for the river sand, and also tile waste as an aggregate for domestic concrete. Again, research with University of California, and we are working to use bottom as an alternative for fine aggregates. And another good area to work out is the CDW, construction and demolishing waste. You can see every building has its life cycle, after life cycle, you need to demolish it. In Sri Lanka, unfortunately, the CDW have been used as an earth filler, but we have sand issues and so many issues, and I'm sure that we will run out of with virgin materials. We have to really work on this subject, and we are working on that. And also roof tile as a solution for overcoming autogenous shrinking, and also usage of PET bottles in concrete, and also low-grade limestone. We have many low-grade limestone in our quarry, and we are trying to, it's again waste in our quarries. We are trying to, circulate this resource. And also rice husk. Yes, I explained that we can use rice husk as a fuel, but also the 50% of rice husk generations are being used for rice mills, and they're getting at least 15 to 20% of ash. This ash is just dumped. So we are working to see the possibilities to develop reactive silica from this ash, and also interesting other solutions to use waste fatty acids to overcome plastic shrinkage in concrete. There are many futuristic thinking research in this area, but in order to commercialize this thing, we need support from government, and also we need to have a good business case to justify our investment. With that, let me stop here. Thank you very much.
All right. Thank you, Mr. Viris and Sanjeeva. Yes, so this is where I stopped before. So it's really great to know about the initiatives that are done in Sri Lanka, and I mean the pathway to a circular economy. If you understood the concept before, it's sometimes it's a vision, it's a goal, it's a philosophy, and I mean every country, every economy, I would say, would take perhaps multiple iterations to get to that final point, if it's achievable at all. So whatever we do is actually an increment towards that, in that path, along that journey. It makes we are making progress. So what I'm going to do next is to share with you some global best practice case studies, and especially in the area of circular economy. As I mentioned before, the circular economy talks about basically having biological and technical nutrients circulating in the industrial cycle, or in an economy, in a useful way that they can regenerate within the economy. So Ellen MacArthur Foundation, which is a not-for-profit organization based in the UK, who advocates and promotes circular economy at a global level. This is one of the diagrams they have released on how circular economy is to be sort of operationalized. So there's another simple version of the diagram which actually talks about all the like the key concepts or principles in in three using three principles. So the examples that I have taken are in line with these three principles mainly. So the first one is regenerate natural systems. So similarly, what I talked about before, if we are taking some nutrients out of the natural system, how best can we replace them in nature? So that is the idea of regenerating natural system. Second one, design out of waste and pollution. So if we are having a certain I mean, if the current way that we operate, the current economic model, if we pollute, reducing that pollution, and if you are generating waste, how possible it is for us to design the system in a manner that we reduce waste generation and minimize pollution. The third one, keep products and materials in use. So if we have actually, if we have already spent a certain amount of environmental footprint to produce a material, rather than considering it as to be, I mean, as waste, or requiring it to be reused or come back to a cycle, how can we actually make products, materials, and components in use? So these are the three principles that is basically, I would say, that would simplify how to operationalize a model of circular economy. So I've taken 7 examples. Actually, it's more than 7, but I've sort of aggregated them. So let's go one by one. And so this is where the examples relate to. 3 of them relate to design, 4th and 5th relate to the production part of the circular economy, 6th one to distribution, and the last one to consumption. As I told you before, it's about designing parts of the system as a whole, but contributing to a part of the system at least, which could cover upstream as well as downstream activities. So the first one is actually coming from the global thought leaders of circular economy, cradle to cradle principle. So as I mentioned before, it's I would say the fathers of this concept is Michael Braungart and William McDonough. So they talked about the fact that in a typical scenario, that our typical manufacturing paradigm is that we produce products, and the things that we try to optimize are performance, cost, and aesthetics. Whereas we should be thinking of having eco-effectiveness as a criteria, where we try to optimize ecology, economy, and equity. So their work in the last 2 decades have basically materialized into different programs and practices. And one of them is this Cradle to Cradle Product Innovation Institute, which has introduced a certification, which call it C2C certification or Cradle to Cradle certification. So there's a product certification system existing where they classify I would say assess materials and certify materials, and provide a pathway for them to be coming to, or rather provide a pathway for them to align with a circular economy. So the criteria that they usually use in the certification now, first one is material health. So basically reducing the toxicity of the material or any subsequent recycling processes that come after that, so that handling is easier and the material streams that it's ending it up with is not basically hazardous and need to be dealt with separately. The second one is material reutilization. The ability of the material to come back and be used in multiple cycles, renewable energy and carbon management, producing it with low greenhouse gas emissions, then water stewardship and social fairness. So what Cradle to Cradle does is basically getting a material, conducting a complete assessment, and then proposing what is the current baseline, and then providing a pathway to improve. So basically, if you have the certification and you sort of take the actions along the pathway, the materials get more and more aligned to be directed to a technical or a biological cycle. So that is the first example. So that is a global best practice case study, which is sort of, I mean, the ultimate that we can reach when we get in line with the principles of a circular economy. And this one is some examples about a few projects that is currently happening at Deakin, which some of them are current projects and some of them are completed projects. So the first one is textile waste. So the practice that is the principle that is related to this one is design out pollution. So this is a project to design a new process or process innovation to basically replace dyeing in textile. So dyeing, you may know already, but dyeing is a very energy intensive process in textile manufacturing, and it is also very, it consumes resources quite extensively. So 36% of the total greenhouse gas emissions relate to dyeing in manufacturing a garment, and each pair of jeans emit 30 kilograms of carbon dioxide and need 3,500 liters of water. So the process that is being introduced is basically to, it's called the wet spinning process, to recover the dye out of the textile material. For denims, it's blue, and then pre-treat it and use a method called ionic dissolution and use a technique called wet spinning, and then have the yarn produced again. So basically it would replace the dyeing process to and apply the new material can be applied to textile. So this won the global change award, H&M Global Change Award for 2017, and this is an innovation basically done by the Institute of Frontier Materials, which I've mentioned the logo here. It's an institute within Deakin where there are 200 material scientists working under one roof, and they work primarily on two objectives: innovating, or rather creating materials for a circular economy, and creating materials with extraordinary functionalities. And some of the other projects, commercialized research projects they are working on currently, are like this. So first one is long-lasting waterproof coatings that don't generate PFAS when manufactured. So the water repellence of the material is basically achieved with some ingredients which generate PFAS, and then displacing fluorine chemistry. And then lighter clothing that can keep you warm with using less materials. Basically, like warm clothing, you need a lot of insulation materials. So how can you achieve it with using less materials but having thermal insulating properties? The third one, long-lasting textiles that shed fewer microfibers. So the pollution from textile actually not only come from the disposal of the clothes, but also every time we wash clothes, we add microfibers to washed water, which finally ends up in natural waters and ocean. And so how can you basically have clothes designed so that it sheds fewer microfibers? So the examples actually go on like this. The other one is using pea silk. So pea silk is I was when I first heard the term, I was wondering what it was. So pea silk is a silk where you so usually when you manufacture silk, you get the cocoon by killing the silkworm. Basically, you like the cocoon is obtained with the as a whole. So pea silk is a silk where you basically let the cocoon go and then you obtain the silk. So it's like cruelty-free silk. So replacing oil-derived material with some of the ethically sourced material is another example. This is one of my like favorite examples to explain some of the other innovations that happen. So what you see here is a set of is a pile of windshields. So these windshields have glass and also have a component called PVB, which is there to give strength. So these are architectural glass or like glass which can be used, which are used in construction or any other material, any other application. So having PVB makes it difficult to recycle, and also the other option is to crush it and use the crushed waste in landfill, which is a downcycling option because you don't recover the full material value. So the innovation that is happening in this area of like two separable layers of glass, and then the polymer layer coming in between. So basically, as glass is an infinitely recyclable material, you have the polymer layer. If it can be dismantled or rather recovered separately, that would basically add a lot of value. So the two applications they're trying out at the moment is to have it in a manner that it can be unzipped, and you recover the polymer layer, and you recycle glass separately, and you recycle polymer separately, or crush it, or apply heat, or how can you basically separate them and recover them having the material integrity. So that's the idea that they're exploring at the moment. The third example is a bit of a different example. So I think this is the principle, or the principle that it relates most to is something called co-design. So co-design, if you think of design of materials, design of products, design of components, who should get involved in design are not only material or product designers or customers or just the people in the organization. It should also be people who do recycling, because recycling poses some constraints to dispose the material at the end. And if the people in recycling can talk at the time of design and tell that, look, we can't recycle this, it makes a huge difference. So that is exactly what is happening with this application. So this application called PREP, Packaging Recyclability Evaluation Portal. It's a web-based tool developed through a collaboration of all these parties mentioned here. So Australian Packaging Covenant Organization is a not-for-profit, like an industrial body, and the other two are not-for-profit and a private company. So what it does is to assist the packaging designers to design so that the packaging material they end up with can be recycled. The evaluation portal, if you're a packaging designer, you would go and enter the details of what you plan to design. So you enter the material, whether it's plastic, HDPE, LDPE, paper. You can design a bottle, the lid, and the neck ring, all that. So you put the design details in there, and also you select the material, and also select the composition, and it gives a report to you whether the material is recyclable or not. So how they have enabled this is by surveying the available recycling options in the country. Through surveying the recyclers, that they identify that some of these things are not recyclable. Certain combinations are not recyclable. Having some materials together are not, it doesn't give an option to recycle them. So it basically poses constraints to the recycling process. So if the designers understand those constraints up front, they can basically alter their design so that it is recyclable. So that is what this tool basically enables. The fourth example is an example where we can actually, if the waste is already generating, if the waste is already generating and we are thinking of different ways to deal with it, some of the examples the examples that I take here relate to that. So the use of waste-derived products in construction. So this is an example where waste plastic, already collected, already generated collected waste plastic, is being explored to use in a construction application. And the application is load-bearing construction applications like columns and beams and all that. Because in Australia we have a lot of wood-based buildings. This is definitely an option that is being explored. This is done by two of my colleagues at Deakin University. So what they have done here is basically having different material configurations so that they use less material, but then keep the density and the strength of the material intact. And they're testing them to explore what way should they basically manufacture the material. So if they manufacture the grains vertically or horizontally, and then how would the strength be if the comparison with the virgin material, if it is recycled first time, for a second time, multiple cycles. So this type of studies, that would sort of give an idea. It's a waste that already generates. You're exploring a different market for that waste through exploring the properties of the material, and designing a new product for a new market based on the inherent strengths of that application. So that's the core idea in this one. And a low-hanging fruit, I guess, for all of us is this is what I actually did my PhD on. use of waste concrete in structural concrete. So if we have demolished concrete crushed, we get a product called crushed concrete, which has a fine component, like this is called fine recycled concrete aggregate, and a coarse portion. The coarse portion has a residual mortar in it. So basically, it's not 100% similar to the natural aggregate we usually get from a quarry. But this product can be used to replace some portion of natural coarse aggregate, so that we don't have to quarry the natural material. And to do that, you might need to change the mix design, because the recycled concrete aggregate has higher water absorption. You might need to use plasticizers. You might use alter the mix design, mixing processes in a way that it gets comparable and similar properties as possible. So this area is an area which is being explored very extensively in the world at the moment. So performance aspects of this product, recycled aggregate concrete, and what makes it possible for us to get it as close as possible to natural aggregate concrete. But if you think of this, the system is not designed to be regenerative. It's less optimal, but it's a possible practical circulation. The ideal would be that if we are able to design the concrete in a manner that it is separable, it's easily separable, and this is possible, that would be the ultimate goal to achieve in a circular economy. The fifth example that I have is again a different one. It's a Collenberg industrial symbiosis. So once again, the practice here is not about optimizing the design of a product, but optimizing the performance of a set of industries as a network. So Collenberg is a city in Denmark. It looks like this, close to the sea. And what is there is a set of industries, mainly who represent industries in the biotechnology sector. So Novozymes, for example, is one of the world's leading producers of enzymes, insulin. So what they have done basically is connect them in a manner like this. So each of the industries have some dependency on some of the neighboring industries. They operate as a cluster. They exchange waste heat, waste water, and other materials. So they have basically linked up or connected in a manner that one company's waste become a raw material for the other, and the structure is optimized. The interesting part about this network is that firstly, they have been operating for about 30 years now, and they are not designed as an eco-industrial park. So they were not designed to exchange materials in the beginning, but they evolved to do that. The network has both public and private enterprises. So there's the public water authority, public utility authority, and a public council, like a governmental organization, plus a range of private parties. So if you think of the how they evolved, every time there's a change in the business environment happened, so that one company's material supply got affected, or a company started producing additional waste or a byproduct, then they tried to find a dependency from another company where they could rely on that material, they could take that material and use that material. So if you take these two incidents, for example, 1987, Novozymes needed large volumes of cooling water to produce enzymes and pharmaceuticals. So they probably would have done a production upgrade, and then the Collenberg municipality supplied cooling water from Lake Tiso. What happened in 1993, environmental legislation banned the discharge of sulfur compounds into the atmosphere. GPROC receives gypsum from arsenates. So basically, the companies acted, though they are different private and public companies, they had different income statements, different balance sheets. They acted together to have the mutual dependency created in a manner that creates advantage for them. And that's an excellent example for collaboration and partnership in industrial networks happening in a manner that it enhances the business as well as environmental performance. So the all of these companies, they create mutual financial benefits by the exchange. So they increase competitive advantage because they rely less on external supply and rely less on markets, or rely less on other waste treatment methods. And they all have improved environmental performance. And the figures are quite amazing. They collectively, what they achieve together from the exchange of energy, water, and materials. And they are basically continuing to evolve in that way. So I'm having a research project with the Collenberg Industrial Symbiosis currently to analyze the role of public authorities, how the public authorities intervened as a change agent to the evolution of the network. And I think this is one of the areas that is very relevant and applicable to Sri Lanka, because we operate export processing zones, and the work that Professor Alvis is doing in this area, I think would very much, I mean, this is sort of a case study which could be, I would say, give a lot of lessons to all of us. The sixth example is a quite different one. So I'm coming to the area where we talk about how to make distribution in a regenerative manner. So in the economic model, production, distribution, and consumption. So this is an example which relates to the distribution part of it. Selling light as a service. So the key question asked here is that why do we need a product when what we need is a service? So this is a quote by Thomas Rao. So this is actually a case study by Philips. Instead of selling bulbs, they at a certain point it sparked an idea to sell a service. So what Thomas Rao here tells is that, look, why do I need a light? Why do I need to buy a light? I have to buy a light, I have to service it, I have to replace it, I have to discard it, or I have to put it into waste at the end. Why do I need a light? What do I need a light for? Instead of, why can't I actually buy, why do I need a bulb? Why can't I buy light as a service? So the pay for performance model, the whole idea of that comes from that we actually, in an economy, what we need is to consume things, and we consume things to fulfill a human need. And that human need is a service that we need, but we don't need to own products to fulfill that need. So in this example, there's a pay for performance. Basically, you are paying for illuminating units. You're paying for how much illumination you get through the light rather than paying for the light. And how it operates is that Philips installs and maintain the upgrade of the system. They install lighting services. They repair it and recycles the equipment. And the consumer, the one who gets a light as a service, pays for the light. So rather than paying for the bulb, which they have to take care of and discard or treat later, they pay for the service. And another example is washing machines. Pay per cycle for wash rather than paying for the washing machine. So the ultimate idea here is that is to overcome some of the weaknesses of the ownership transfer model. So the product, I mean, if you think of a washing machine, for example, how many of us know what are the components and materials in a washing machine, and what are the, if you think of a component, what are they actually made of? So we actually don't have the perfect information or the knowledge to think of how to repair it, or how to basically treat that material to the right material cycle. So even if you behave in a responsible manner, we, as a custodian of a product, if you buy a product, we don't have that skills or knowledge. Whereas in a ownership transfer model, what we do is to transfer the product ownership is to be retained with a party who has that knowledge, who has control of the supply chain, who has access to manufacturing, who has access to repair services, and the people who want to consume the service will buy the service from them rather than buying the product. And it's also easy to physically call back the material, because let's say if you want to discard the washing machine, you have to think of a number of electronic components and the plastic, the structure. But if the company owns the product, you ideally have a source that you can revert the product back to at the end of the performance cycle. So this is an area where there's a lot of opportunity and is being very widely explored all around the world at the moment. And I think National Clean Production Center has a lot of trainings and initiatives in this area on chemical leasing, how to basically, it has the same concept. You pay for performance of chemicals rather than buying chemicals. The last example is a very simple one. Again, the simple question asked is, so we are going to the consumption. How do we differentiate consumption? Or rather, how do we make consumption that we consume less, or we have material going in the economy like for a longer time? So why do we own things when we can share it? So we have this concept for books, usually libraries. And so that we don't need to own books, we need to buy books, we don't need to keep books, and we don't need to discard books. So same concept for toys. People who use toys, kids, they outgrow the need for toys within a very short time. So why do we actually produce it and sell it and have it accumulated, or have it as a burden, whereas we can actually have a service to get access to them, use it when we want to use it, and then have that service coming through as a membership. So this is happening currently in Melbourne, where we have a few toy libraries happening, like operating as social enterprises, so community volunteer activities. It's happening around the world, especially in the post-pandemic world, because we are concerned about touching things and like, using something that somebody else has used. There's another initiative called Thingery.com practice in Europe, where you can actually have contactless exchange of tools that you use, things like spanners, drills, and other things that you need. Actually, you don't need them very often. You need them once in a while, but you have the ability to share it rather than to buy and use it on your own. So that comes to the end of the examples that I'm sharing with you. I've written down 3 key lessons here that we can take from most of these global best practice case studies. First one is that correcting an unsustainable economic model needs multiple iterations. So we, on one hand, we are trying to we are making progress with downstream activities. We are trying to make the waste disposal less environmentally harmful. Like in the case of INSEE, we are trying to manage the downstream activities very strongly and trying to promote options in the upstream. We have some of the things that I shared with you relates to design. Some of them relates to reducing the impact in production. Some relate to distribution, some relate to consumption. So there's no way that we can correct a unsustainable economic model as a whole. We do what we can, and we may need to do multiple iterations, address different points at different times, and starting the journey and understanding where we are heading is the most important thing. But the best way to address it is through design, change of design. The second point is that solutions in a circular economy cannot be achieved by one party alone, because we're thinking of redesigning an economic model, and there are multiple parties along even one supply chain. And science and economics and business need to work hand in hand in doing that, because there's a part where there's material product and component development. There's a part where you need to redesign supply chains, analyze economic feasibility. So it's very much a journey where science and business has to marry together and go. And all of the projects that I've shared with you are not the result of an overnight success. They have been there for a long time to get to that stage. Some of them for over a decade, and they are the collaboration between industry, government, universities, industry associations, they have been essential to develop these partnerships. So because each of us play a role, and the role that we play sometimes, I mean, the difference that the transformation we are trying to make is actually beyond us most of the time. And for businesses, the transformation in the long run actually creates value and competitive advantage. I mean, resources are finite, so you basically reduce the supply risk, and also you help yourselves in managing future environmental liabilities, and restructuring a model for better competitive advantage and better productivity pays off very quickly. So that's it, and I hand over to Mr. Pires again.
Thank you, Dr. Mayuri. Now, our final speaker today is Professor Ajit Alvis. I think he doesn't need any introduction, but I think as a courtesy, I will say Professor Ajit Alvis is a professor in Chemical and Process Engineering at University of Moratuwa, and who has contributed immensely in promoting science, technology, and innovation in the country. He was CEO of COSTI, and his involvement in these fields over the many years has contributed a big way, not only in academics, but also to the industries. Over to you, Professor Ajit.
Thank you, thank you. After hearing all those examples, it's inspiring, and we should ask the question, what we should be doing. And also, I think one of the key messages is that these situations can generate employment and opportunities within. Something that we should be looking at this post-COVID scenario. I'm not sure about exactly the post-COVID, but this situation where we are facing immense economic issues, and new business models are being identified, and how we move into this direction. So let me switch off the video and share the screen to give some additional thoughts in to support what has already been presented. I hope it's visible.
Yes, it's visible.
And this is a picture of our linear economy, the result of a linear economy. And this is Karadiana from air. And you have these huge garbage mountains, a small composting unit. If you see the green roof and the side, it's interesting. In about 1 hour's time, I should be there. And but this is a result of the linear economy. And we consume, we push waste to the outside, and these water bodies, the wetlands, all these get contaminated. And few miles down the line, university, we also get the smell, and perpetual smell for a long time, depending on the way the wind flowing. So these results are obvious, but so the need to change is there. What you see is that if you have been looking at, I encourage you to look at the Circularity Gap Report coming from the World Economic Forum now, which actually is a group of CEOs who are looking at to push the world into the circular economy, I mean themselves. So it's called the Closing the Circularity Gap. And what you see is this coalition is called PACE. It's the accelerating the advent of circular economy. So like pushing for that. What they show is that if you look at the material value chains globally, only 9% of materials get recycled. It comes back. So there's a huge waste of 91%. And that's the gap that we have to fill. But I think if you look at Sri Lanka, in the Western province specifically, we have more data. Our circularity gap, I mean, our recycling is about 3% that we get data. So, so we have a huge gap, and even with the current norm, we are way behind in terms of recycling. But the world is way behind from the where we want to be. And we understand this, the issue that comes from, I'll touch on both sides a bit. So like fast fashion, when we have been promoting, and we have seen the very bad results, like in the most significant, or the garment textile industry disaster that happened in 2013 in Bangladesh, where about 1,000 workers died in the collapsing factory. And it's a race to provide fashion. It's a race to meet the needs of the season. And sometimes you may be stitch on the go, or I mean, kind of thing. And you have huge stress in this system in trying to meet. And this is a classic linear economy scenario where we want to keep pushing, and we want to show, okay, summer fashion is not this summer's one, and we have to make them outdated in the minds of the user. You need to buy more. And we expect our growth model to based on such consumption. So the Kenneth Boulding, who actually the economist who came up with the concept circular economy in the naming, if you notice the World Economic Forum, it's now called circle economy. So use of words, but it's essentially the philosophy that we need to tap into, understand. And Kenneth mentioned that anyone who thinks you can grow the economy forever on a finite planet is either a madman or an economist. So it's a very interesting comment to show that if you have been looking at this 3%, 6%, 10%, and so on, and then we are very unhappy when this year becomes 7%, when last year was 10%. That's the wrong way to do things. And I think virus showed that to China in some way. But the point is China has now taken on the concept of circular economy, as well as most of the Europe, and Europe very seriously into a circular economy. Japan into recycle economy. So we see major nations and nation groups moving into that thinking, because that's what is required today. And virus also gives us a chance. As I said, we are now contemplating how to get the businesses going, how to reduce our job losses, and so on. So it's, I mean, this offers us a chance to think differently and move in a direction that actually give us new business models, give new different opportunities, and actually makes us more resilient and much more stronger. And so it gives us an opportunity, and I don't think we should miss this opportunity. So I think this discussion is timely in that way. But if you look at the world, we have always valued resources, and maybe we are going back in that thinking. So if you look at an interesting example of London, if you look at 19th century, and if anybody has been reading Charles Dickens on his last book on this, Our Mutual Friend, I would have seen this kind of names, and these are all resource recyclers. Of course, they were not at the height of the, I mean, like they're not in the top end of the economy or the society, unfortunately, but like bone pickers to showmen to toshers and pure finders. And I just take on pure finders, interestingly, just to emphasize, there are about 100,000 people if you look at this example in London at the time. And also remember that at this particular time, we were under British, the Colombo, but this is London, right? So pure finders, the word pure is actually is the English colloquium for dog shit. So these people, their job was to find dog shit, and their sole business is their sole job is finding dog shit and collecting this pure and basically taking them to tanneries, right? Because deliming process and the way they did at the time was making use of the dog shit as the raw material or as a chemical. So it's very interesting. So if we look at toshers, and that's what the Charles Dickens in his book mentioned, is about collecting coins from dead bodies that were lying around in London or nearby. So that is the state of that, because you find that, okay, we don't have resources, but we need these resources to run this. So we need mechanisms to collect and bring the resource back. Of course, later on, the empire that's the sun never sets found that you can get your resources from all over the world rather than going this way. So the scenario changes. And we have industries. I'm pretty sure Sanjeeva can imagine an interesting advertisement like this for that, to because this is world's #1 chemical industry, BASF. What they're showing is that the executives looking into the bin to come up with the resources, and because they know you can put in, you can really give value to the waste, and the waste into vital resources. And this is something we now have to again learn in a serious way, and build that into our local economy, because circular economy actually looks at somewhat of a closer economy, but without losing touch with the outside. It's not a purely a closed one, but we look at most of the parts as circular. So even with, it's interesting to see when one country produces, now this is a lesson to Sri Lanka. Really, I want to draw that because Sanjeeva explained a lot of examples now as INSEE and community is doing, and you have numbers to do that. But still, in our economy, we have not understood the strength of this way forward. That's why we don't keep creating new jobs and business plans based on this thinking. So take this Chinese lady, Zhang, she really became the first billionaire woman in China. I'm not referring in yuan terms, I'm referring in dollar terms, right? who actually was, her first job was really scavenging cardboard from the Los Angeles landfills. So US was practicing a linear economy. So they're throwing everything into the landfills or the dumps. And then here you have this person walking in, collecting cardboard, shipping them back to China, and developing them into cardboard packaging, which brings the goods back from China to USA, closing the loop. And she still has the world's largest this cardboard factory, if you look at Nine Dragon. And overall, China benefited from US's linear economy method, because come Christmas, you end Christmas, and then you find almost all the wires, the bulbs, and all the electronics and all the electrical stuff being thrown away. So all this Christmas lighting and everything ends up in Chinese warehouses. So it's a very interesting look at economic thinking to see when we see this, these resources powering the Chinese economy when they change. Of course, today, the China is not bringing waste in, and a lot of other countries are now having trouble with what to do with the waste. Of course, circular economy is the framework to go, right? And so China really benefited from somebody else's linear economic behavior, and they understood and practiced it in a large way, in a very good way, and bringing technology in to make use of these resources and transforming them into the factory of the world, factory to the world. So it's all, if the US was practicing circular economy, I'm pretty sure the Chinese economy would not have been like this. They would never have had the growth pattern that they had. So we have to come up with this new framework, and an example of quite biological thinking is the waves from World Bank. We have countries, a few countries now doing this. Again, as a webinar, in a sense, we are exchanging information. So we are trying to get people to consider this, and decision makers. So this is a new, instead of GDP, you have this wealth accounting and valuation of ecosystem services. This has been in place for some time, because we understand GDP is not a way to do business. And unfortunately, we are still thinking on GDP. And yes, we can still think of GDP, but if you communicate that we know better, that is very important. Then it will be reassuring that we know that our decision makers know what they're talking about. At the moment, we still harp on GDP, and we harp on 1%, 2%, 3% GDP growth. And it's so unfortunate that we have not understood what we should be doing. And so waves really is valuing ecosystems. So an example, the World Bank publishes every year the annual Green Book, and you can see statistics like data valuation. And if we do this, we will really understand better. So bees and their pollination services, they have looked at bees are giving 153 billion service to the economy from insect pollination. Of course, the bees won't get a bonus, but if humanity recognizes these benefits, the humanity gets the benefit. Now, what happens is we sometimes lose the bees, and we look at how to get our agriculture productivity. And that's the connection that we have lost, and that's the connection we want in circular economy back, and all these waves and so on. So we have a framework. And I would like to say this as a chain economy. So if you move from the linear economy, probably we have to next move on to a chain economy, because we cannot immediately go into the circular economy. So we still may have some resources coming, still may have some waste, but we are very much focused on changing the chain economy even to the final circular economy. So even from recycling, we go up into upcycling. And so this is our ultimate, and we can be very happy. That is much more, this is a more of a sustainable model than whatever we have been practicing before. And this decade, where we head to 2030, we need to accelerate this framework. So it's very important. And Myri really emphasized on these as models. And so this is what Ellen MacArthur, the foundation, has been championing this whole new. And I only would add one to this, because it says extracting raw materials, part supply, manufacturing, distribution, and we as a user, and we as the economy, can we have our service models? Can we have bringing refurbishment models? Can we bring in parts harvesting models and recycling? What I want to emphasize is we should really be seriously focused on not having incineration and landfill. We should move away from this business of incineration and landfill. And that will be the truly business models driving the circular economy. So examples Myri mentioned, so it's like even for e-waste, we should be looking at, I remember we first did the e-waste survey for Sri Lanka and came up with this concept, but we found that nobody really is interested in refurbishment and pushing it down. There can be so many children who can benefit from a situation like this instead of always looking at the new one. Even Abdul Kalam used second-hand stuff and his quest to when he's learning in Chennai. So it's not always the new one won't immediately guarantee you will hit success. It's your attitude that matters, and the society can do with this type of recycling models. That business models are missing. And also there are a lot of tools, a lot of concepts, adding on to what Myris has mentioned, like if you look at this disrupt, I hope you see these presentations and so on. So it's in the circularity gap because the disrupt. So even putting like the incorporate digital technology. So the Uberization of resources where you don't own, but you actually get the benefit, like the Philips lighting concept, like the chemical leasing NCPC is well known, but unfortunately still not been decision makers are not putting that into practice very much in agriculture here. As an example, we have in the newspaper industry being used in Sri Lanka. We have it in wastewater treatment. These service models, right? There are a lot of things where you now bring in IT. So design for the future. You design out pollution. So those excellent examples that mention all means multiple different business models, ability to generate different livelihoods options and empower our economy rather than the economy that we are having today. The slightest mistake, we are just done. We have to beg for resources, beg for support from the outside. And like that C2C, the certification, so developing circular products is very, very important. So a good example, I would say is a very strong one is like in Singapore, where they knew that they don't have water. And from day one, they started recycling. And if you go into Singapore, when you drink new water, you are drinking basically recycled sewage, right? And of course, they are masters in the technology of membrane technology, was number 1 or 2 in that area, because they were fulfilling their water requirement from these recycling operations, collecting rainwater, etc. That's what I think, like if Parakram Bahu, the King Parakram Bahu was to born to Sri Lanka today, he would really migrate to Singapore very fast, because his practice of not a drop of rainwater should move away without being used is more practice there than in Sri Lanka. We are just wasting almost all the water that we bring in, and we purify water and wash our cars. And so it's a serious way of wasting resources that we practice today. So this is understanding one resource line and then working towards that. So we have examples like when Dr. Palmer came up with the zero waste city concepts. It's actually not in his country, but that in Japan that this first came up with a zero waste city, Kamikatsu in Japan, and where the individuals separate the waste streams into about 31 separate waste, depending on the nature of the waste material, and all of them going back and forth into the use. So ideal circular economy in practice in a town. And you have these examples of like Kuru shop, right? And model Kuru is in Japanese, it's circular, and those who know Japanese maybe pronounce it right. Where you actually, it's like the Melbourne toy factory, but going a step beyond. You bring something that is not working and you pick something that is working. So you actually exchange it and somebody is there who will put it right. So it's a step more from the practice of, so this Kuru without our own Sinhala, I mean, without complaining, I think we should have these models coming in, because there's so much that one can do probably with some of these mindset changes that to our economy. So an example for what we should be doing in a broader way, like when you go to Kandy, you see this garbage. It's a close-up, otherwise you don't miss it. It's on the Kagwal bypass to Kandy when you're on the way to Kandy. And you just dump garbage on the top. on the hilltop. It's crazy, right? And but this Dr. Maksud, writing from Bonn University and analyzing Sri Lankan composting systems, and saying if you practice circular economy of composting in Sri Lanka, there's $0.5 billion USD worth. And you don't have to beg from anybody for this. This is all what is there internally. But only thing is we need to come up with the reverse logistics. We need to come up with the mindsets. We have to come up with people talking to people, organizations talking to other organizations, and then working together to get the value addition. And this is compost plus chemical fertilizer blends coming, agriculture waste coming. So like example like this, if you see the Clear Point residencies in Rajagiriya, now this is the world's tallest vertical garden building. So interesting, right? Now, the potted material from here comes from Rajangane. So you have all this, so now these are the things that one should develop, but how can we cut across to the entire agriculture? And how can we cut across, now as I said, no incineration, how can we cut across with entire organic waste in Sri Lanka? How do we get into the biogas and then change across to waste is the input, electricity and compost is the output. That's exactly what $0.5 billion, what Professor Marx was mentioning. So you don't have to go and ask for loans, it's all built in. And why can't we make use of changing the septic tank to a biogas pit for the home, because we are not going to get centralized sewerage in Sri Lanka. And if you change like that, you actually get your in-house fertilizer too, but solve the methane issue, but you get gas into the cooking and you save your LPG. And so these are things that one have to do. And very quickly to finish off, we can have regional symbiosis, and Mayuri was very clear with the Denmark example, the world's first. And Sri Lanka has this option, go from province to province, we can develop this. For example, this is the coal power station, and we have next there, we have the coal power station, we have the agriculture, we have a Putlam industrial estate, we have the INSEE cement factory, we have the Raigam salt factory, we have a construction material factory for fly ash. Now all these people most of the time works alone in silos. But this is exactly what should not be changed to industrial symbiosis. Only the construction material factory came to Putlam next to the coal power station knowing the ash is there, right? Rest has been organic. Salt factory operates without even looking at the coal power station. They are using the reverse osmosis and they can jolly well use that and so on. So we have examples. We can go from that province to the Ua province. We can make the sugar factory as a center to that Ua province, and sugar centered. We can run on the alcohol, we can run on the sugar, we can run on, as you can see, a horticulture and a lot of other things, even agriculture production. So these are an example the British sugar is doing. So example we can use with desiccated coconut industry. We have water, coconut water. Only last year, we started putting a product of this nature into the market. And Mr. Pires may remember, long time before in even 90s, we were talking about this opportunity for the DC industry. And you go to Moratua, we have 6,000 metric tons of sawdust per month coming out. And all that is put into the Verasganga and so on, or just burned to get the EPL to run the sawmill. So it's so unfortunate, but we can run an industrial ecology system like at the in Hexham, you can see where you have your wood, you have your timber, you have your chipboards, you have a lot of other things coming out, and an industrial symbiosis happens. And you come with new industries and you make use of. Today, the 6,000 metric tons per month is a problem to the economy or ecology at Moratua. It's a burden to the economy. It should not be a burden to the economy. It should be a productive asset to the economy if you follow circular economy principles. So finally, so thanking. So actually we should, there's so much of opportunities in Sri Lanka and to be very specific and employment. So I think we have a chance now, if you think on this line, to fund the banks to think differently and put these funds and introduce this new business model right now post-COVID. Thank you, because circular economy is a sharing economy. It's a caring economy. Over to you, Mr. Pires.
Thank you, Professor Ajit. I think since a lot of time has been gone, I would like to go to questions quickly. There are a few questions, I think, in the already actually posed by the participants. There is one question, I think, could you please let me know the best way to dispose zeolite, which is used to absorb into gas? I think it's open, probably Professor Ajit can, I think, give a better answer.
I'm not sure I read the question, but I'm not sure why the person has a worry, because zeolite is like aluminium silicates, and then you are scrubbing nitrogen.
Yeah.
So that cannot be hazardous or anything. So I'm not very sure what's the problem in the, it should very well be going. It's a zeolite is a very wonderful catalyst material. There should be a very easy way to plan out and reuse or even dispose of it in a constructive way. I don't think it's a problematic path at all. I didn't give the exact answer, but it's not a hazardous waste.
Yeah.
That's what I'm driving at.
Yeah, it has, I think, its values. So probably we don't have to dispose it.
Yeah, I'm sure Sanjeev can find a way of organizing a loop for that.
Sure. Before do anything, let me connect to them to see exactly the profile of this waste, and then we will find a solution for sure.
Yeah. I think that person can contact Sanjeev and probably get a solution for this.
Sure.
The other question is the paper, hardboard, all these are recycled. In the meantime, clothes are being wasted by burning or burying. Is there any possibilities in recycling clothes? Probably Dr. Mayuri can, I think, answer this.
That I presented are very much in a research and commercialization phase, so they are entering commercialization. Once again, I mean, it would be a great opportunity to explore, because in Sri Lanka you have a lot of apparel and textile manufacturing clusters as well as standalone companies having high production volumes. So definitely there's opportunity to basically recycle waste, but I mean, at the moment, one of the other things that is happening is that with the China ban on accepting contaminated material, there's actually there's possibility that Sri Lanka would be also getting externally imported waste coming as well. The design for recycling options are still at a research to commercialization phase. But of course, if there's a possibility to change the design, that's one option. That option to recycle, I think, still is basically shredding and the other, I mean, using it as an energy resource in Sri Lanka at the moment, I guess. When these technologies come, I would say more into commercialization, that would be worth to explore. I'm not sure whether Professor Alvis has anything to add.
Yeah, interestingly, yesterday night I was the external examiner for 2 research projects at Moratua from Material Science and Engineering, and those 2 research students have worked on you taking this microfibrillated and nanofibrillated cellulose fiber from rice straw and the other from waste cotton, the textile cotton, and also come up with usually it's cotton blended with polypropylene, this polyester. So identification of how to have the blend and handle the blend for this MFA or NFA. Now that's fiber. Of course, we need to have an investment on sulfuric acid. Hopefully, when we are doing this for sulfuric acid plant to be coming in for the fertilizer, that will give us more sulfuric acid access. So acid treatment and then delignification and getting fiber, we can probably do away with asbestos. And so there is a significant value addition with these nanofibers being made available from the natural sources. One is rice straw and one is a waste cotton. So these options are there. Of course, you need to have some investment. That is why you need a national roadmap, that we do change to a circular economy principle. We identify the gaps and do some critical investment in the right places so we have these issues solved.
Yeah, I think I would like to extend this question to a different level, Dr. Mayuri. What is the local customization requirements if you want to actually have the international practices in the country, in Sri Lankan industries? What customization requirements are there?
It's quite broad. I think. I mean, going by what Professor Alvi says, if you think of the low-hanging fruits are the ones which need low investment, less reliant on government or like a systemic change. So I would say things like sharing models, but of course it has to be backed by proper behavior change as well. So the discipline that you need to have in sharing, as well as the ethics and all that, you need to basically integrate them. So sharing models are low investment and pretty easy to implement. And in terms of pay for performance models, I think again they are not practices which need high level of investment or high level of R&D. Companies actually can sort of investigate on these options fairly easily. The ones which involve material research or the ones which involve product research, they are the ones which actually need, take some time to do research, need investment, need university collaboration or expert collaboration. So they are to come as more like medium to long-term options, as I see. But again, even when you do that, if you take a sector like textile and apparel, which has a high volume, and you do a small change there, it can impact a large volume of waste. So I guess you have to prioritize in that way to think about it. Professor Alvis, do you have anything to add?
No, you said.
Okay.
Yeah, I mean, it's like to me, if I take that Dr. Maksud presentation analysis, we have $0.5 billion kind of like opportunity with composting. Just local councils coming together with a strategic investment, it's not much investment, but working together, you have this opportunity. And 0.5 billion for Sri Lankan economy is quite a significant sum.
Yeah.
I would like to put the next question to Sanjeev.
Yeah.
There's a question, is there any solution to household waste? Can you suggest something?
It's again, broad questions now. At the moment in Sri Lanka is dumping. Why? Because it has not been properly segregated. And people are not really segregated, as Professor said, there is no solution as such. I think first thing is to integrated waste management concept has to be established, especially at least local councils need one, local council need one. But when again, like household, again, we went into details like how, when you go to household waste, we have seen pharmaceutical in it, we have seen CFL bulb in it, we have seen so many other hazardous waste in it. So we have to think the segregation from the house has to be established, and then only we can find the solutions. But we have to develop this area.
Thank you. I think the next question is to Dr. Mawari. Can you give some ideas on recycle aggregate and how would be it in its strength?
Yeah, so generally, like if you think of not designing of concrete to be circular, if you think of the general concrete that we have already built, demolished, and if you produce a recycled concrete aggregate out of it, we kind of consider it as a material which has inferior quality to natural aggregate. Sorry. So currently, for example, in Australia, these standards are being updated very rapidly right now with more research and more results coming. It's mostly being used for applications below 30 megapascal, and usually used for non-structural applications. So things like pavements and even applications which doesn't have load-bearing capacity, or does not require. It doesn't say that it cannot. So a lot of the mixed design methods, mixing methods, and material research evolving, even introduction of nanomaterials to concrete. So all of these are contributing actually to make the process of recycled aggregate concrete equivalent to natural aggregate concrete. So that performance part of the research is material performance part of the research is still evolving and still to come and reflect as standards and specifications. So for the moment, it is still at 30 MPa. 30 MP for non-structural, but I think we can expect to see rapid developments in that area in the coming years.
Okay, thank you. One last question to Professor Ajit. Our policymakers in Sri Lanka were focusing more on service-based economy, like tourism or maybe income from foreign-based, say, our employees. So do you think if we want to be a developed country and technically an advanced country, will this be sufficient, or do we have to change our way of the industrialization and way of the economic development?
I think, thank you. That's very straight answer is no. Service-based economy, I think virus very seriously showed us that we have a serious problem if we continue to go in this down the line. We had at one point, 1 month worth of chlorine, we had 700 sobs. We were running out of what was even vital material. And with all the apparel, we were not able to get the N95. So we need to have manufacturing, but of course, manufacturing not in that wasteful manner, but in a circular manner, right? If we continuously have faced this issue of looking at tourists, okay, when even in 2009, we identified when the volcano erupted, the calm environment that prevailed at the time because of the volcano, the tourism didn't come. And so we were disrupted seriously. So yes, if you get the cash flow with that, keep that going, but the resilience of the system plus with ecology, we need to have now eco-based, I mean like eco-friendly manufacturing coming in. So answer is no, service-based.
Thank you very much. I think, let me see, I think there is something I think from Mr. Premchandra. I think IPSL, I have few comments. I don't know whether the technical support can help him to actually make any comments. But anyway, because of the time, I don't want to spend a lot of time. Oh, I think anyway, I think we have come to probably most probably the end, but it's not the end. I think it should be the beginning. Today we were discussing about the transition from our linear economy to a more circular type of economy. We may not be able to directly go to a circular economy as pointed out by Professor Ajit. So we had some good examples from Sanjeeva in the local condition and how INSEE is doing a lot of changes into the business model. And then Dr. Mayuri, while introducing the basic concepts, went into explain globally what is happening. And I'm sure that we can learn a lot of things. There are low-hanging fruits, as she mentioned, and Professor Ajit mentioned, that there are many opportunities available for the country. And Professor Ajit also, I think, gave a lot of examples. Maybe what are the lessons we can learn?
Yeah, basically, thank you very much for all panelists, Professor Ajit, Dr. Mayuri, and the Mr. Senaphiris, and all the listeners. And we were trying to bring something to our nations, to change something to make it circular economy concept adopted in Sri Lanka. There is way to go, and we have to start. I think we or individual has to be the change that you want to see in the future. With that, let me conclude the session. Thank you.